Hello students, now let us discuss about the Venn diagrams used in the concept of sets. So Venn diagrams are used in sets. We show different types of figures to show the sets. We show sets using circles, ovals, even triangles. But you remember that for universal sets we use rectangles and squares. If A equal to 1, 2, 3, 4, 1, 2, 3, 4 is a set, I will show this using Venn diagram. Normally, we include sets in universal sets. So here, for me, let me take a set of natural numbers as universal set and set of A having 1, 2, 3, 4. Inscribed in this universal set, that is n, using a vowel, and I have named it as A 1, 2, 3, 4. Now there is a simple question. If nothing is given as a roster form, and of course if the set is a non-empty set, how to show? So let me take a set B non-empty set. For this I have to show it as a Venn diagram using a universal set U and set B through shading, because it is a non-empty set. So B equal to like this. Of course, you can use different types of shades. I have used in horizontal format, you can use in vertical format or cross or anything as you like it. All of us know that 5, that is empty set which has no elements. Let me try to show this in Venn diagram. I have taken a universal set U, and this I have to show a null set or empty set or void set or 5. So in my opinion, I am just drawing the circle and leaving off without any shading. So this is this one shows so without any shading is like this only. shows a void set or empty set or null set. We have different types of names for empty set. I made it without shading because there are no elements. There are no elements in the set of 5, that is empty set. So I have kept it without shading. Two sets are given like that. A comma B are non-empty sets if A is a subset of B. A is subset of B, that is, it is shown as like this. We have some different types of application on this concept. First one is how to show A union B. So we have already discussed that A is subset of B, that is it is universal set U. So B is bigger than A. Small set A, or let me write this like this, and a set B comprising the elements of A. So the question is to show A union B. A union B. So all the elements of A belong to the elements of B. So simply I will shade both of the diagrams for A and B, and this shows A union B equal to B. A union B equal to B. So we can show this A union B like this, and it comes the point if I have to show or find A intersection B. So we already know that A is subset of B. So A, B, and universal set U. I have to show A intersection B. So A intersection B is the set comprising the common elements of both A and B, and the set of having common elements is A itself. So simply shade A enough. A intersection B equal to A. A intersection B equal to A because A is subset of B. I want to take two cases. One is where A union B are not disjoint. In another case, A and B are disjoint. So here, that's why I will divide this board into two parts. Now, here A comma B are not disjoint. Here A comma B are disjoint. And in the first instance, I want to go for A union B. So they are not disjoint. So for anything, any operation, let us not forget to do in universal set U. And of course, choosing universal set depends on the conditions or definitions for the sets we take. A, B. So I am taking A union B. like this. If they are disjoint, of course, we all know that the meaning of disjoint sets is the sets which have no common elements. So they are having no common elements. So how to show? How to show this means simply I am drawing two non-intersecting circles, but the shading is of the same kind. This is A and B for disjoint sets. Next, A intersection B. Intersection means the set having common elements in both A and B, and it is enough to shade this part only, intersecting part only. So it is for A intersection B of non-disjoint sets, or if they are not disjoint. So if A, B are disjoint, how to show? Of course, in books there is no such discussions for those I made in the previous time, but in my point of view, AB, there is no scope for shading. How to show A minus B? So universal set U, A, B. So A minus B is the set having only the elements which belong to set A. So shading like this. These are not disjoint. If these are disjoint, these are disjoint. This shows A minus B equal to A itself for the disjoint sets. Next, B minus A. So B minus A means the set having the elements belong to only B. So this shows B minus A. Now these are disjoint. This shows B minus A. A minus B union B minus A. This is of course A minus B, B minus A, C. This is like this. Next for design sets. A minus B union B minus A. So A minus B is A itself, B minus A is B itself. So simply like this. So next, if I am asked to shade like this, A union B minus A intersection B. I am going to do this in the sets which are not disjoint. A, B. So here if you observe A union B is shaded like this, and I have to remove A intersection B from this. How to do that? So observe A union B with horizontal lines. For A intersection B, it is included in A union B itself, and A union B minus A intersection B. I have not covered the vertical lines here. So it shows A union B minus A intersection B. If you observe carefully, in the first kind of shading, only using horizontal lines A minus B union B minus A, I have not covered. I have left this part as unshaded, which is A intersection B. Now coming to this A union B minus A intersection B, I have shaded A union B in horizontal lines, of course, as usual. But for A union B minus A intersection B, I have left the vertical lines uncovered. This intersection part I left uncovered with vertical lines. So you can observe that A union B minus A intersection B is equal to A minus B union B minus A. For this, how to do? A union B minus A intersection B. Of course, these are disjoint sets. For A union B, I have shown using horizontal lines, but for A intersection B, there are no common elements, so there is no scope of conducting any operation. A intersection B is a null set, so completely it becomes A union B itself. So like this you can show, and from the both we can observe that A minus B union B minus A is equal to A union B minus A intersection B. So A minus B union B minus A is equal to A union B minus A intersection B.